All right, so 2.3, more on functions and their graphs. So we're just kind of continuing on. And so we're going to look at increasing, decreasing, and constant functions. And so this first part's going to be pretty technical. And so I'll talk about it, but then I'll also try to just kind of break it down into simple terms. So right here it says a function is increasing on an open interval I if f of x1 is less than f of x2, where x1 is less than x2 for any x1 and x2 in the interval. Okay, so once again, most of you might be kind of thinking, what the heck is this? Well, let me try to break this down a little bit. So basically, they're saying you have two x values, okay? And so x1 is going to be the smaller x value compared to x2, right? So in any part of this interval, right? This is just one example of this. And in that case, the f of x1 and f of x2, those are just referring to the y values. Remember that function notation is just stands for the y. So the y for x1 and the y for x2. And what that means is that the y for x2 is larger than the y for x1, the first x value, the smaller x value. And so what's happening here is basically the y value is increasing from left to right. So if you just look at this line, just follow it, it increases, the y value is increasing from left to right. That's really the easiest way to think about it, okay? Now this definition here was much more tedious, but if you are going to major in math, if you plan on going through calculus and taking some of your analysis courses, you're going to use a lot of language like this, okay? For us, really, like I said, just the easiest way to think about this is if it increases, you want to read it from left to right like you would a book, then it's increasing from left to right. The decreasing, same idea. You can see it kind of it decreases pretty quick, slows down, but then it continues to decrease from left to right. So this would be a decreasing function. Once again, the formal definition uses some of that symbolism here with the f of x1 is greater than f of x2 and so on. And then our constant function is just that the y value stays constant. It doesn't increase or decrease, it's staying the same. So what's going on here is you're just describing the behavior of the y value. That's what we mean by this. So what's happening to my y value as I look from left to right. And so that's all this really is. And so I'm going to even break it down a little bit more so I can explain how we're going to describe a graph. So right here it says increasing, decreasing, and constants describe the behavior of the y values as you read the graph from left to right. You are being asked to find the domain of the interval, or it could be multiple intervals, for which these behaviors occur. So what's going to happen here is we're going to give you a graph, and we're going to ask you, okay, where is the graph increasing, decreasing, or constant? And so your answer is the domain for that interval where that's occurring. So for example, right here, the first question is, where is it increasing? Well, you can see right here, it's increasing, 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 and so on right here up to this point right here, up to about right here. Now, this graph, um, it cuts off right here, but it's increasing all the way from negative infinity over here. So remember your answers in terms of the domain, in terms of your x values, right? So it's increasing from when x is negative infinity all the way to the left that you could imagine, and then it stops increasing at -1. And we're always going to use parentheses on these, okay? Because -1 is kind of actually going to be a neutral point, because then all of a sudden what happens, it actually starts to decrease. And so then the function's decreasing right here from -1 to +1. So remember, your answer is in terms of the domain, so you're focused on x. The behavior is the increasing, decreasing, or constant part. And then you can see right here, all of a sudden it goes constant. The y value is not increasing or decreasing, it's staying exactly where it's at, and that's occurring from 1 to 4. From when x is 1 all the way when x is 4, it just stays flat. It's not going up, it's not going down. Then our graph starts to increase again. So we're increasing, 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 and so on. And so that increases from 4 to 5, from when x is 4 to 5. So sometimes they're going to use the notation where you just kind of put a comma but I like to use the union symbol, and so you'll just have to look on your homework and see how they want you to enter that. So sometimes you'll just put a comma between your intervals. I'm going to use that union notation. So from 4 to 5, from when x is 4 to when x is 5, the y values are increasing. That's what this is describing here. And then we go back to just being flat right here. So then from here, we're just flat all the way out to positive infinity. So I'm going to union this in. So from 5 to infinity, it's going to stay constant. It's not increasing, it's not decreasing, it's staying the same. And then we're going to get a little extra practice with our domain and range here. They're going to ask us to go ahead and list the domain and range. Well, you can see that this thing goes left and right indefinitely. We go from negative infinity to positive infinity, so and everything in between. So our domain's just from negative to positive infinity. And then the range, well, let's see, this thing goes down indefinitely. So if you're looking at range, remember sometimes we tie it to the y-axis just to kind of help us visualize this. It's going to go down indefinitely, and it goes up to 4, then back down, and then up to 7. So it's going to peak at 7. So that range is everything from negative infinity up to 7. So you got to put the negative infinity first, and then comma 7. Now the 7 we're going to bracket in because now we're talking about domain and range again. And so that 7 is included as part of my range. So I want to bracket that in. So whenever we're talking about increasing, decreasing, and constant, we're always just going to use parentheses because like I was saying, those points where it changes from increasing to constant or something like that, those are going to be like our neutral points. And so as you're approaching it, yeah, it's increasing as you approach it. And then as you're leaving that 5 right there, you're going to stay constant, right? So just always going to use parentheses with those. All right, I think I have one more of these, and then we're going to look at one other definition when it comes to functions. So if you'd like, go ahead and pause the video and see if you can answer this on your own. Okay, so I'm going to start. I'm just going to do this from left to right. So I'm coming from negative infinity over here, and I'm just staying flat. I'm just going to stay flat all the way until I get right here. So that's going to be constant. So from negative infinity to, it looks like 1. I'm just going to stay flat. Then I start to decrease here, decreasing. And that happens from when x is 1 to when x is 2. And then I go back to being constant. So then I just stay flat right here. And let's see, I'll union that in. That's going to be from 2 to 5, it looks like. From 2 to 5, I'm going to stay flat. And then let's see, then I'm going to increase. I haven't had that yet, so I'm going to increase. My function's increasing. And that happens from when x is 5 to 7. So from 5 to 7, I'm going to increase. And then the last part again, I'm going to start decreasing. So remember, this is just describing the behavior of your y values, and it decreases indefinitely all the way out to infinity, because remember, we're talking about the x values. Our answer is in terms of the domain. So we're going to union that in, and let's see, that's going to happen from 7 and then continuing on to the right forever. So we use that infinity symbol. And then once again, the domain for this one is just going to be everything between negative infinity and positive infinity. And then the range is going to kind of be similar to the last one. So once again, you kind of want to focus on the y-axis. How far down do I go? Well, it's going to go down forever. So that's going to be negative infinity. Well, how high up do I go? Well, the highest I get is 6 right there. So my range is going to be from negative infinity to positive 6, and we'll bracket that 6 in. All right, so that's increasing, decreasing, and constant, how you can kind of describe a graph. The next part we're going to look at is these things called relative maximums and minimums. Once again, you're going to kind of see some of this formal definition that gets a little tedious, okay? And so let's just talk about maximums and minimums to start with. So if you look at this graph, it actually doesn't have a maximum because it goes up indefinitely and it goes down indefinitely, so it doesn't have a minimum either. But we have these things called relative maximums and minimums, and that's where basically you look at a subsection of the graph. So this relative minimum right here, you're just kind of looking at this part of the graph right here. You kind of block off everything else and you're just looking at this little part right here, and you'll see this in a second. Basically, a relative minimum is the smallest y value in a subsection of a graph that has like a little dip in it. You have a little dip in it, and so it's going to be the smallest y value. So whenever we hear maximum or minimum, we're talking about the y value. And then once again, you give your answer in terms of the x value. And so in this little example right here, there's the relative minimum. And then if you want to look at the relative maximum, it's kind of the same idea, except now you're looking for a bump. You're looking for a little bump in the graph. So either you look for like a little dip or valley, okay, or you look for a little bump in the graph. And so relatively, this is the highest point for just kind of looking at this little part of the graph, or relatively, this is the smallest point, smallest y value for this part of the graph. And so that's kind of basically it. Sometimes you will, so a lot of times we call them relative, but sometimes they're also called local. Sometimes they're called local. Sometimes they're even called neighborhoods. So do you have a relative max or min within the neighborhood? And so you're just talking about the surrounding area, basically. So let's go ahead and try one of these here. So use the graph to find each of the following. And so the homework should pretty much look like what I have in this boxed area. So right here, part A says the graph has a local maximum of, so if you look, it doesn't actually have a maximum because it goes up indefinitely, but a local maximum, you can see that there's a little bump in the graph right here, a little peak for this area right here. And so the maximum is referring to the y value. So the y value right there is actually 0. That's what the y value is, and it occurs at when x is equal to 2. And then we do have a minimum, a local minimum, not a minimum, but a local one right here for this little subsection of the graph. If you look right here, we have a little dip in there, and that occurs at when, let's see, the x value is, I'm sorry, the y value is -4, so that's actually what the minimum is. That's the lowest point for this little subsection right here. That's the smallest y value for this little boxed area, and that occurs when x is equal to -2. And then you get a little extra bonus. You get to answer increasing, decreasing, and constant. So you can see that we start off decreasing as we follow the graph from left to right until we get to that minimum, that local minimum. And that's occurring from negative infinity because this graph goes up to the left indefinitely. So we're decreasing from negative infinity until we get to when x is -2. And then once x gets to -2, we start to increase. So we increase. And so we're increasing until we get to that local maximum over here. So we're going to be increasing from -2 to +2. Between when x is -2 and +2, the y values are increasing. And then last, we start to decrease again right here, indefinitely, going down indefinitely towards positive infinity. And so let's see, that picks up. Let's see, so we're going to be decreasing from 2 all the way to infinity. So if you look at this, the graph for the most part is decreasing, except for that little part where we swing up and then we start decreasing again. And then we don't have any parts on the graph where it's constant. So we don't have any of those. All right, and so that's going to do it for 2.3. If you got any questions, let me know.